Welcome to Study Loop.
We're told that oxygen-15 has a half-life of 122.2 seconds, and that oxygen-19 has a half-life of 26.9 seconds. And we know that the ratio of these two isotopes is exactly 1 at some time. We want to find what the ratio of the two isotopes is after 3 minutes and 12 minutes. So the first thing we want to calculate is the decay constant for each of these two isotopes. So in either case, and let's do 15 for now, this is equal to the natural log of 2 over that respective half-life. So this would be the half-life for oxygen-15. And likewise, and for 19, the decay constant is given by the natural log of 2 over the half-life of oxygen-19. So the next thing we want to know is how much initial oxygen-15 and 19 there is at some particular time. So not the initial value, rather, the value at some later time t. So the amount of 15 that we have is equal to the initial total amount of oxygen we have times e to the minus lambda 15, where this is the decay rate of the 15 isotope, times t. Similarly, at some time, we'll have that the number of oxygen-19 isotopes is equal to the initial number of total oxygen in our sample times e to the minus lambda 19 times t. So if we know that the initial value is the same for each of these isotopes at time t equals 0, then it must be true that N19 over N15, the number of, or let's reverse this just to keep it consistent with the problem, the number of oxygen-15 over the number of oxygen-19 must be equal, if we divide these two equations, to e to the minus lambda 15 t over e to the minus lambda 19 t. So now this is a function where we know all of the variables, and we can plug in for the time at, first of all, 3 minutes, and then after 12 minutes. And then doing this, it's easy to see by plugging in values and keeping our units consistent, but after 3 minutes, this ratio has a value of 37.23, and after 12 minutes, this ratio has a value of 1.92 times 10 to the 6th.